Hello everyone, and welcome to this Redshift versus Karma XPU render review video. For the past month, I've been consolidating lots of information. I've been running tests, creating diagrams, and really taking a thorough deep dive into both Karma and Redshift because I want to know which render engine is best for the students that study at CGForge. I've also found that this choice in render engine makes a pretty big difference for just about everyone. As an example, for beginners, this is often the difference between somebody burning out or sticking with it. For intermediate users, this will help them get a better looking demo reel and hence get a job somewhere. And for studios or advanced users, a great render engine is often the difference between working late into the night with stressful overtime or having a normal work week in a healthy studio that's staying profitable. That being said, one of my top priorities here is to be as objective and non-biased as possible. I don't want to favor either Karma or Redshift. I'm not sponsored by SideFX or Maxon either. The reason why I'm making this video isn't to tear down Redshift or Karma. It's to help artists build up a competitive workflow so that my students at CGForge, as well as myself, can move forward into the future with the best tools possible. That being said, if you find all of this hard work that I've done to be helpful, then all I ask is that you please share it online wherever you can. Now, in order to do a proper assessment of these render engines, I've broken this down into 5 main categories: speed, features, visual quality, user experience, and pricing. These are the main factors that ought to go into one's decision making when determining which render engine is best for the situation. And that is why we're going to be judging both Redshift and Karma based on these factors. Just so you know, this is intended to be a more advanced video. There's a lot of ground to cover, and I can't explain every single concept along the way. That being said, also feel free to pause the video, ask questions, and do your own research in order to understand some of these things that I'm talking about if you find yourself lost along the way. This naturally brings us to our first criteria: speed. If you'd like to run these tests for yourself, I've included a link that allows you to download this scene file, which has 9 different setups included. We're going to go through all 9 setups here with the testing, and the goal for each one of those setups is to try to determine how each render engine handles a specific situation. For example, this scene right here is an all-purpose test. We have a variety of shaders. We have a directional lights, area light, point lights, various size lights, essentially, and even one of these shader bots is a emissive material. So the idea is to throw a little bit of everything in this scene and see how things go. Most often with these scenes, it'll start here at the object level, and then if you go to the stage, we bring it in and turn everything into USD information. The idea is that if there's any speed benefits or disadvantage to USD, for most of these tests, we want to remove that as a factor. So on the left-hand side, we have the Redshift tree. That's where our lights are. That's where our materials are. We then cache this out. We don't always cache it out, but here we do. And then on the right-hand side, I've copied all these nodes and done the same exact thing for Karma. One thing you'll find, though, is that the settings and the visual quality between Karma and Redshift does not match up. So as a result, I often have had to try to go through here and change material settings, change lighting settings to try to get it fairly similar to what the other was doing. So there is some artistic liberties here in the sense that because these settings don't look the same, I have to go in there and adjust them every now and then. But the goal here is to make them as similar as possible. And throughout these different tests as well, you'll see some notation where I mention some of these changes that have been made. In order to gauge my computer specs here, I would also rely on Afterburner. Afterburner is a plugin from MSI that allows me to view the computer specs that are being used right now, or to get an idea of what's happening with my computer. Now, we can see at the top here, I have GPU usage as a percentage. This is how hard my graphics card is working. The memory. This is not the memory that's being used, but the memory that's reserved for my graphics card. Memory usage by process. This is the stuff that's actually being used. So whenever you see VRAM, it's talking about this memory usage as a process, not the allocated memory. We also have our core clock. So this is the GPU core clock, CPU usage, the CPU core clock, and then the RAM usage down here. And these are the various specs that I would look at when this is rendering, and you'll see this notated on the slides here soon. The reason why I'm using Afterburner rather than the render logs is just in case the render logs paint a prettier picture than was actually happening here as measured by a third-party tool. The resulting render is then what we see here in these slides. One of the first things I talk about is the time to first pixel. And the way I measure that is I hit render in the Karma viewport, and I literally hit play on a stopwatch on my phone at the same exact time. So this is not relying on the time to first pixel as reported by Karma or by Redshift. This is, again, independent of whatever the render engines say. I hit render, I go with this, and whatever time that is to me seeing something pop up on the screen is the time to first pixel. The reason why I do it in the viewports and not via Husk is because the time to first pixel really matters when you're shading and lighting. So how long it takes something to pop up in your viewport with a progressive render is where the time to first pixel matters, because you don't want to be waiting there when you're trying to shade and light your scene. The next thing I talk about here is the sampling mode. With Redshift, it is possible to do adaptive sampling. With Karma XPU, it is not. Karma XPU only has the ability to do a progressive render. So in order to make the most fair comparison that I can, what I would do is I would start with Redshift. It would be set to adaptive in most of these situations. It would go for, let's say, 17.5 minutes, like we have right here. And then when I go to render with Karma, I would do a progressive render and have it cut off after 17 minutes and 32 seconds. So it would be a time-limited progressive render, so that if Redshift had 17.5 minutes, Karma would have 17.5 minutes as well. You'll notice that there is a little bit of a discrepancy though, and that's because the pre-processing time is not recognized by Husk when it's setting these time limits for rendering. So sometimes you'll notice that Karma gets a little bit more time than Redshift, but that's primarily due to the pre-processing time, which unfortunately means that there's a variance of maybe about 1 to 10 seconds in most situations that Karma has extra over Redshift. But for the most part, they get about the same amount of time. After that, you'll find the render settings, as well as the various limits that were made for both Karma and Redshift. Those limits make a pretty big difference in most situations. The scene specs, the hardware performance, so that's when I was looking at Afterburner right there, as well as some shading notes. Any miscellaneous notes, so if I crashed, if there was a bug, if there was anything weird when setting this up, that is mentioned in the miscellaneous section, and then the hardware specs. There's only one test where I actually have a different set of hardware specs just to see what it's like when you have a really beefed up system, but these hardware specs are consistent for the vast majority of the tests. Both Redshift and Karma XPU allow for hybrid rendering. That means using both your CPU and your GPU to render out an image. So for the vast majority of these tests, I turn that on. One last thing I want to mention before we get to all the tests, that is when it comes to color correction, I would render out everything as scene referred data. In other words, information that does not have any sort of color correction. Then once I'm here inside of Affinity Photo, I would go OCIO. We would set this to ACES CG as the inputs space, destination, outputs, sRGB. And then sometimes, like with this cloud, because it's a bit of a hazy scene, I would also go here to the levels and I would tone map this a little bit. So I would take the whites, bring this over, leave about 10% wiggle room. I would do the same to the blacks. And by doing that for both Redshift and Karma, it just allowed us to see a more similar image when comparing the two. Now I want to give you an opportunity to browse these test results without my commentary, and then afterwards I'm going to pick out some of them and add additional things to say. When it comes to stability, I had about the same amount of issues with Karma as I did with Redshift. The main thing that was causing a lot of crashes was the viewport. So anytime I would render something, switch back to OpenGL, and then try to reset the render engine for both Karma and Redshift, that would almost always crash me. In total, I crashed over 40 times. That's not an exact number, but I can say at least 40 times I crashed. I'd like to make a few additional comments for some of these tests here as well. For the Shaderbot lineup, you'll notice that the lighting is not the same. I come to find out, after about maybe 4 or 5 tests later, that the HDR rotation is not the same between Redshift and Karma. For whatever reason, you have to twist that thing about negative 90 degrees in X in order for the HDR to be the same from one render engine to another. Also, the light exposures were not consistent. Sometimes a light would be pretty similar for, let's say, a point light in Redshift and a point light in Karma, but if you got a directional light, that in particular is where sometimes I needed to bring things up a full 6 stops in order to get a somewhat similar exposure between the two. That is a lot of what you see here when there is a difference between the lighting. Also, I want to say that with the materials, the way that I did this is if there was a parameter, like let's say the melanin parameter in Redshift and a melanin parameter in the Karma hair shader, those settings needed to be the same. The idea is that if you have something that describes the same thing and the value range is the same, assuming that they are using the same formulas, which they should be, then you should expect consistent results. In the case of Redshift and Karma, that's what I tried doing right here. And for the record, I also did try troubleshooting the glass shader, the hair shader, and the rough green shader that we see here, the rough refractive shader. In spite of troubleshooting, I wasn't able to get a very similar look. So I tried doing the same settings from one to the other, and I also tried just doing whatever settings I could to make it look similar. And in both cases, that didn't really work out. So I went with the shader here that uses the most similar settings that I could. When it comes to the tessellation test, this took quite a while because I kept running into this bug, this memory leak bug, where I would notice that the RAM would just go up and up and up and up for a full 2 hours before blue screening my computer because it just took up all the resources and crashed everything. This is true for both Karma and Redshift. Just anecdotally, I've noticed this more so with Karma than I have with Redshift. I ran into this issue probably about 10 times. I didn't actually keep track of how many times, but it definitely took more than a day or two to run this whole test because of that bug. And it's something you need to watch out for as well. What I found fixed it was changing my camera angle. So I'm guessing what happened is that it, for some reason, kept subdividing certain areas, and that's what caused that RAM leak to happen, where it just kept on making polygons. Just to guess here, but that's what I'm referring to when there was that bug of a memory leak. We'll also notice that Bubble Blob had some unique issues as well. With Bubble Blob, Karma had this black section here, and the way that you fix that is by turning up the number of refraction rays. What's interesting though is that Redshift also had 20 refractive rays right here, yet it still looks like we are going through this entire bubble. We're not actually going through the whole bubble, but it looks like we are because Redshift doesn't allow that black artifact to happen. So even if you don't have enough refractive rays, Redshift will still try to give you some kind of refractive look to everything, and that is certainly a plus just when it comes to the visual quality of that calculation. At first glance, that might not seem like a big deal, but it is if you're rendering something like foam, as an example. If you had a river simulation and you had some bubbles that are moving around, it only takes one little moment where those bubbles overlap too much to cause those black specks to start showing up in your render, assuming that you're trying to render those bubbles with actual refraction. The other thing that's interesting about that is with a scene like this, you can probably get away with less refractive rays, which will greatly reduce your render time and still give you a pretty looking picture that's convincing. So if you did have foam and you wanted to cut down your render time because it was taking too long, with Redshift, it is possible to do that by taking down your limits, whereas with Karma, you'll end up with those black artifacts. Another thing that's unique about this test is that I decided to go with a progressive sampling mode for both Redshift and Karma. The reason why I did that was just to see how the progressive mode would perform. So, if let's say in this case you wanted to have more control over exactly how long something took, maybe adaptive wouldn't be the best situation for a highly refractive object like this. So instead, that's why we go progressive. I set it to 2048 samples on Redshift. In this case, that took 49 minutes. And then for Karma, I set the time limit to 49 minutes as well. Obviously, that leaves you with this issue, so you have to crank up the refraction, which brings it to 40. We still do have some black specks in there. For whatever reason, I couldn't get rid of those even when I took up the refraction limits even higher, so I'm not sure what's happening there. But when we turn on dispersion, it created a lot more pre-processing time. Everything got a lot noisier here as well. And again, for the thin film, which is what you would want to do in this situation with Karma, that took, again, about 49 minutes based on a time limit that was set by 2048 samples using Redshift. The next one here is Caustics. And in order to get this set up in Redshift, it is a little bit tricky at first to learn, but once you understand it, it's not so bad. This uses photon mapping. So it literally tries to figure out how the light is bent, and it goes through the glass, it goes through the liquid, it colors the resulting, I guess, light particle. And that's how we get these caustics. Karma XPU did not have a good time with this. We technically do have caustics, but they are very, very, very faint here. And I did try to post on the forums with side effects and on the Discord. I was asking if anyone had success getting caustics to work. I tried spending pretty much all day getting this to work, and by the end of the day, I figured, you know what? If I can't figure this out, then I'm sure the average user probably can't figure this out either. So that's why I labeled this as bugged. It just doesn't really work. And if you want to see more details as to what I did, then make sure to read this slide. Next up is the interior scene. Between Karma and Redshift, you'll notice that the colors are different because of that HDR rotation issue. Now, in spite of that rotation difference, it shouldn't make a big impact on the actual render time or the noise that's resulting in this room. One thing that was very annoying about this scene was when I set up the camera, we can see right here, this is what I saw in my viewports. The crop is not the same as the crop that I got when I actually rendered this out via Husk. So it was very difficult to get a similar crop on everything. You'll notice that the lens distortion is different. For the most part, Shaderbot takes up about the same amount of the frame between Karma and Redshift, but for whatever reason, when you set a custom resolution on a camera and you try to render that out with Redshift, it does not actually show you that custom resolution in the viewports. It does not render that custom resolution. So the only fix I had after this test was already done, and I come to find out later, was to set it back to 1920 by 1080, a common resolution, and then this bug went away. Also, something mind-blowing about this test was the fact that when I used irradiance caching, it took 6.5 minutes to render this image. Being that we don't have irradiance caching with Karma, it took 1 hour, 10 minutes, and it was still far grainier than what we have with irradiance caching. Now, I know all of you critics watching might say, well, but if it's animated, then irradiance caching might give you some, artifacts and things like that. Which is why I set the irradiance caching settings up to a higher quality to prevent that. And I would also like to say that many interior architectural designers don't need animations. They just need still frames of interior scenes like this. So for that reason, irradiance caching is still a big deal, and even if this was animated, it would still be worth it just for the amount of time you save at render. For the volume rendering, I want to give a shout out to my buddy Yasser Shams for helping me out with this one. Yasser has a monster machine. It has 2 graphics cards, specifically two 3090s that are liquid cool. It's a custom setup. This is a really high quality machine that I wanted to test on the clouds just to see what it's like to really throw some firepower at it. Something that's really interesting about this test is that XPU performed worse than a GPU only render. I know, that sounds crazy. When we turned off the CPU and we just rendered with the GPUs, it was faster by a lot than it was when we had both happening. The reason for that is because when you have a heavy scene like this, when you have an area of clouds, like let's say along here, that takes a very long time to calculate, those CPU buckets can take many, many minutes and get stuck in those areas. When that happens, that's what increases your render time, and that's when it's better to just use a pure GPU solution as opposed to an XPU situation. When it comes to motion blur with Karma, I wasn't able to get this to render. It simply just froze for about an hour and a half until I had to kill Houdini and crash it. If you want to see the steps that I took to try to resolve this, I've listed them out right here. The bottom line though is that even if I am missing something, this workflow is not intuitive enough for the average user. And so even if I did miss something along the way here, my argument is that it's too complicated, it's not stable enough, there's not enough safeguards for somebody to enact a very common feature such as motion blur, and for that reason, it absolutely fails this test. Last but not least, we have the instancing test. And what's interesting about this is that the time to first pixel was actually faster by about 5 seconds with Redshift than it was with Karma. The reason why that's interesting is because one of the touted benefits of USD is the fact that it's really, really efficient with instancing, that it gives you a lot of speed and performance boosts because everything is essentially referenced to a file. However, with this example here, Redshift is not going through the USD workflow. It's simply just using points and the instance file attribute to read RS proxies from disk. And when that happened, it was much faster than Karma in getting to that first pixel. So that's very interesting. The other thing that's interesting that I found with this scene is that when you adjust the softness of a area light with a gobo, the softness that you get with Redshift is much better. It's much more realistic. So when you have the sharp edges of the image with the gobo and it spreads out evenly, that's what Redshift does. Karma uses some other algorithm that creates these weird noise-like shapes when you have just a little bit of spread in that area light. So in this case, it wasn't easy to get the same exact lighting for that reason. But in spite of that, we got somewhat close here with these two renders. With Karma, the color was also off. I'm not sure what was happening with these stems. I checked the shader and it was supposed to be the same thing, but it just looks different for some reason. But there you go. That is what's happening with these two guys. Let's now carry on with features. For this, I asked myself 3 questions. What can Redshift do that Karma cannot do? What can Karma do that Redshift cannot do? And then what are some of the main features that are most important to people's workflows? And does Karma and Redshift have those features, or do they not have those features? Again, these features are subject to change over time. Things are always changing, so double check to make sure that whatever feature you care about is either supported or not supported. But as of recording, this is what it looks like. You may have noticed that with Redshift, I mentioned some features that might be releasing within the next month, whereas I did not do so with Karma. And even though it looks like I'm playing favorites there, I'm not. The reason why is because Redshift has a public-facing Trello page. You can go to that page and see exactly what the developers are working on right now. Karma, as far as I know, does not have something that is equivalent to that Trello page. And so that's why you'll notice that some of those features are coming up soon with Redshift, whereas with Karma, I'm sure there are features coming up soon, but there's no public way of knowing that. And so for that reason, it's not included here in this feature comparison. Let's now talk about user experience, starting with documentation. In general, I've found that Redshift's documentation is pretty good. There's a few topics that could use a bit more attention, specifically related to USD and Solaris-based workflows, but the vast majority of things here are pretty well described. One thing that's really nice about Redshift's documentation is that it has these GIFs in here that show you a range and give you an animation of what happens when you go across that range. That's really helpful when you're trying to not only understand something, but know which kind of values might be best for your situation and how they might actually look without having to do a bunch of test renders. When you look into more advanced topics, such as irradiance caching, that can be a little bit difficult to learn and understand at first. And I think that Redshift does a pretty darn good job at giving you a combination of theory and practical advice so that you're not spending too much time struggling with this stuff in order to get what you want out of it. As an example here, we have a couple of diagrams. This is explaining the general process of irradiance caching. We also have pros and cons, what it's good at, what it's bad at, and as we go down here, we have this how to use. So there's not an assumption that you know how to use this stuff. And sometimes documentation struggle with that. They might just tell you how something works or what this parameter is supposed to do, but it doesn't actually give you the practical side of it, which is how do I use this? How do I control this to make a better image? So in that sense, Redshift's documentation makes a potentially stressful situation not very stressful when the average artist goes to do this stuff for the first time. The one area I did find lacking is the current documentation for the USD workflows. Some of this is outdated, it hasn't been updated yet. Some of this is missing topics such as motion blur, and there's an argument there that says it's not Redshift's job to tell you how to use Solaris because Houdini developed Solaris, or SideFX developed Solaris. But at the same time, if someone wants to have motion blur with Redshift in Solaris, I think it should be included in here just because that's relevant to what people are trying to do with Redshift. So that's the one area where I think this could use some improvement. By comparison, Karma's documentation struggles quite a bit. As an example, we have all these different Material X nodes. And what you'll find is that most of these Material X nodes don't even have documentation. As an example, I have this triplanar node. When we bring up the documentation, we see something like this. And in my conversations with developers at SideFX, I've been saying for years now that it's really, really important to actually have documentations for all of these different nodes. What ends up happening is this. Material X is not developed by SideFX. It's developed by a different set of developers. Just like USD is not made by SideFX, USD is created by Disney. And so what happens is that when there is some kind of documentation that needs to happen, they just copy and paste whatever those developers do into the help documentation here, even if it doesn't explain what anything does. And actually, a lot of these parameters in here don't do anything. They are simply just artifacts left behind from the other developers. And so in order for things to change, they need to set up meetings, they need to have conversations and go back and forth with other developer teams to do anything. And that tends to be why this stuff stays the way it is for years and years. So to make a long story short, and I suppose this is just something in general to mention about Karma, You are stuck as the user in between two teams of developers who are having a hard time communicating. And nobody's really taking charge of what's supposed to happen here. That has resulted in problems like this that you'll often find in the documentation, which for the average user makes for a frustrating user experience. The Karma documentation also sometimes makes the assumption that you know what things are referring to. As an example, if we go to the very bottom of this page here about the standard surface node, and we're trying to look for where to put in a bump map. The only thing we have in here is this. It says normal as an input. Input geometric normal. A world space vector in -1 to +1 range defaults to current world space normal. It does not tell you anything about the fact that this is intended to be where you put your bump map. Another thing that's likely to happen a lot as you're going through the documentation is that it's not always mentioned whether or not this article you're reading is related to Mantra, it's related to Karma CPU or Karma XPU. And that can make for a very confusing time when, let's say, a new user types in render quality and speed, and maybe they didn't read that word there, Mantra, or maybe it doesn't even say the word Mantra. You're just going through this article thinking that this relates to XPU, when in reality this article might have been written 10 years ago. You just don't know because they don't mark things as legacy or they don't mark things as outdated. By comparison, Redshift does mention when things are outdated, and it gives you a nice link to go to if there is a better place to read up on something. Let's now talk about color correction. From the Redshift render view, if we say File, Save As, and we save out a JPEG image, by default, everything lines up. If we send out a JPEG from the out context, and we go here and just render to disk, we can see that this also works just fine. Now let's switch this over to EXR, starting with the render view. When we zoom into the face, we can see that there are some slight differences between what we have here in the render view and what we have here in Affinity Photo. Now the reason for that is because by default, Redshift does not have this checked on. You need to go to Outputs, PostFX, and then under HDR files, you need to turn on the color LUT controls. So that's kind of a sneaky default. And honestly, it would be much better to have that checkbox as part of the save image as, or at least to have something here in the options so that you can not have to, go searching through a long list here of settings in order to get consistent results. So that's one area where Redshift does not do so well when it comes to user experience. Once we turn that option on and we go back to Affinity Photo, you'll notice that this definitely gets washed out. We are applying 2 sRGB transforms on top of this image. And so when you check on that checkbox, you're baking everything in, which means that you need to leave the image unmanaged in order for this to perfectly line up with what we have here in the viewport. I found that you'll get the same results if you say render to disk as well. By comparison with Karma, you're going to get different results depending on where you render this out. So let's start with the USD render ROP right here. When you actually say render to disk, I'll save out a JPEG as well as an EXR, and let's see if that lines up with the viewport. By default, the JPEG does not line up. The EXR also does not line up. However, instead of it being an exposure issue, it's a color issue. Take a look at the highlights over here versus the highlights over here. The one on the right-hand side has a lot more saturation. That's the image that I saved out as an EXR. So by default, that does not line up either. Let's now try saving out a test render as a JPEG from the viewports. So let's say that, again, you want to send this over to a colleague real fast. We'll click that button on the bottom left and then save out this image. Fortunately, that does line up properly. Something that's definitely a con with Karma is that when you say render to disk, nothing pops up. It looks like nothing happens. But what it does is it creates a background process where it's rendering the image. You have to manually go up here to say render scheduler to actually see what's going on. But even this isn't totally ideal. When I was doing the speed tests, this happened a few times where I accidentally picked the wrong camera, or I forgot to assign a material properly, something like that. And because I didn't have visual feedback as this was rendering, I wasn't able to catch those issues until it got done with the frame. And sometimes that would be like 30 or 45 minutes later. And so by having that visual feedback, it allows the user to see what's happening, literally, and address those issues so that they can kill the render and start again. So again, it's just one of those user experience things where it gets very frustrating, and that's probably why you would want to render to mplay. Let's try that for our next test. When mplay shows up for the first time, you're likely to see this, a very overblown image. So to fix that, you have to right-click, go to color correction, and then change this 2.2 to a value of 1. And now this is going to line up with what we have in here. Let's go up to File, Save Frame As, and save both a JPEG and an EXR to do that comparison again. The JPEG will not line up to this image right here, and the EXR will line up after you've applied that sRGB transform in post. Let's now talk about the interface as well as general integration. One thing that's not so ideal about Redshift is that it does not show you viewport materials by default. So as an example, if I'm here on the stage and I assign these material builders to the objects with texture maps, that is not going to go through. With Karma, it does, and that's very nice. Same would be true if you went to the object level and you tried doing the same thing. There's a really big issue with Karma that's fundamental to how it's designed here with Solaris and how Solaris is designed in its integration. Let me show you what I mean. When you're working here in Solaris, it's very common for you to be messing around with settings, maybe trying to play around with the visibility of things. So as an example, let's say I didn't like this key lights. So I went down here to the key light, I turned it off, and I hit render again. And let's suppose that I like the look of this render without a key light. And this is what I want in the final render. Okay, so I get done adjusting everything. It's at the end of the day. This is ready for the final thing. Well, what happens is that when you go down here to this USD render ROP and you render to disk, you are not going to get the same image. This is the image that's going to render. It's not going to actually take all your overrides down here and apply it to the render. Even though this is where you were making your artistic decisions, that doesn't carry over. So what you have to do is you need to go down to this little orange button and you need to say create inline USD node from viewport overrides. Once you do that, it makes some code that creates these overrides as a little snippet right here. And then when you go to render this, it will actually have the light turned off. However, there are many issues with this design. And to give you a couple of examples here, if you're working with a pipeline, maybe a lighting TD knows that you need to go up here and create this inline node, but then last minute they did a few other changes. They forgot to update this node. Now we have inconsistent results. We have the viewport based on whatever they were messing around with. We have the override, that is the old override that they forgot to update. And then we have, let's say, what the actual image is. So it becomes a total mess, especially as you're trying to work on a team. And, you know, with the way that this interface is set up, it makes it such that if you're really not careful with what you're doing, you can easily mess this up and you can create a huge mess along the way. The reason why this is specific to Karma and not Redshift is because Redshift gives you the ability to have a non-USD workflow. In other words, I don't have to worry about the stage. I don't have to worry about lops with Redshift. I can just go to the object level here where we have off and on switches and we don't have half of those complications that I just mentioned. Or if you do like USD and you want to do that, then Redshift can work in here as well. But the fact that Redshift gives you that option is also another huge deal when it comes to user experience. If there's anything here that you don't like about Solaris, you're pretty much stuck with that with Karma. Again, I realize there's that out node, but you can't rely on that. And most users anyway are going to try to build things in here. So they're going to be dealing with those complications. In my opinion, I think it's also better to have a dedicated render view as opposed to this hybrid viewport render view situation that Karma has. Let me give you a few reasons why. For one, when I hover my mouse over this window, over the render view, all of my hotkeys relate to things that, are most common with render views. If I compare that to Karma, you have to decide whether or not you're trying to pan across the pixels or pan in the scene because it's also a viewport. What will inevitably happen with Karma is that this will be rendering a progressive render like it is right now. And you want to zoom into this. So what you'll do is you'll hold down Alt and right mouse, but then you'll accidentally jump out of that camera and reset your progressive render, which is not so ideal. Now we're actually tumbling around the scene. And so we then have to go back to the camera here, and then every single time you want to do anything, we have to click the camera down here, choose whether or not we want to pan the pixels or pan the camera, and then proceed from there. So there's just a few extra steps that make it a little less fun to use. Also, if I want to render a render region and I go down here, and let's say I just want to look at the face, you'll notice that it really kind of ruins everything else except for that render region. And that also is kind of abrasive when I'm trying to just focus in on one spot. The fact that Redshift has a dedicated render view makes it a lot easier to implement things like PostFX as well. So as an example, I have all these LUTs that I can change, like that. I can go here and change the exposure without re-rendering the image. I can add a vignette. There are many, many things you can do here in PostFX that honestly make a pretty big difference, I would say, for your average user. The bottom line is that even though you can do all this stuff in comp, a lot of users aren't going to do this in comp unless it's very easy and convenient for them to do it right here. So for that reason, I would argue that the average user is more likely to get a prettier picture from Redshift because all of this is nicely available. And sometimes these post effects can make a very, very big difference. Let's take a look at this lion scene before and after post effects. This is before, and this is after. Another thing you need to watch out for with Karma is that there are a set of hidden display options in this viewport. So if I press D for display, as my mouse is hovering over here, we can see that there's all kinds of settings related to this viewport, and this can override whatever I have down here. Now, this might not sound like a big deal, but sometimes that is a big deal. Maybe you are inheriting a scene from someone else, and for whatever reason, they decided to disconnect this render settings node right here that gets connected by default. Or maybe you're working on a scene and you don't have a render node down yet. And with this, you have, let's say, the background tab where we display environment lights as background. So you have this HDR that's showing up. Well, that HDR can show up based on these settings. It can show up based on the light settings that you have, and that can all change when you come down here to do these settings. So because we don't have a dedicated render view, this can get jumbled up with everything else you're doing over here, and that can cause some complications. Let's talk about these render settings now. How easy is it for someone to dial in the image? Well, with Redshift, it's very easy. You have these different quality presets, and this does a lot more than just setting the adaptive threshold. This goes in there and changes all kinds of settings related to optimizing your scene for a low, medium, high, or very high quality preset. So In my experience, this has worked quite well. In addition to that, we also have the Advanced tab here. And even if you did want to get a little bit more manual with everything, you still have adaptive sampling here. So all you really need to do to control the grain in most situations is just change this threshold. And because we have automatic sampling, it's intelligent at knowing when something doesn't require more samples. And it's about as easy as that. By comparison with Karma XPU, it's a bit of a guessing game. So with these path trace samples, you don't have the option for an adaptive render. And that's a very, very big deal. Adaptive rendering isn't just there to make the image faster. It's there to determine whether or not the image looks clean. And because you don't have that control, you basically just have to go here and say, well, I think this needs 300 samples, and then you try to give it a shot. Maybe that works, maybe that doesn't. You won't know until you see an animation, by the way, of whether or not the grain is too much or too little. And from a user experience standpoint, that means you're going to spend a lot more time trying to figure out these settings and running into frustrations along the way because every single time you're just guessing as to what this actually needs. One more thing I want to talk about when it comes to user experience is again going back to that topic of USD. Because with Karma, you really can't get around using Disney's version of USD. Whereas with Redshift, you can get around that. And again, I realize there's that ROP node, but most users are not going to use that. They're going to go to the stage, which means that you're also left to contend with all the pros and cons of Solaris. And this has major ripple effects with how your artists work. For example, instead of that viewport override thing that I was showing you before, this also means that you need to work with motion blur differently. That requires substepped USD information, which adds a lot of complications, which adds a lot more opportunities for something to go wrong. Same is true for instancing. Instancing is pretty complicated to figure out in its entirety within Solaris, whereas with Redshift, it's a lot more straightforward. You have points, you put an attribute on that point saying where it should go to your hard drive to pick up the RS proxy, and you have efficient instancing. And then for studio pipelines, if you decide to go with Karma, then you're also making the decision to have your pipeline revolve around USD. Again, for mid-size or small-size studios that are competing with Disney, they may not like the idea that their competitor is dictating the backbone of their pipeline. USD also spells trouble when it comes to cross-platform compatibility. So if you have a pipeline that wants to use Unreal Engine or Maya or really any other program, those other programs read and write USD in different ways. And so because of that, it's actually not a very universal format in that there's lots of complications, there's lots of opportunities for things to go wrong when you're reading and writing out that data. And that's not to say that USD can't work well in a pipeline. It obviously works very well for Disney, but the difference is that, again, for small and mid-sized studios, you don't have a team of 20 pipeline TDs ready to go to make sure that everyone's life is hassle-free and bug-free. So you need to spend a lot of resources making your entire pipeline revolve around USD and smoothing out all these different hiccups in order to actually make the most of that technology. Because SideFX decided to make USD the backbone of Karma, that means by adopting Karma, you are adopting all the pros and cons that come along with Disney's version of USD. So again, that is a major thing to think about when it comes to user experience. Your artists are going to have to go through a big learning curve in order to get around the hiccups that USD introduces. And, well, that's going to cost you a lot of time and money. And speak of the devil, let's talk about money, shall we? When it comes to buying Houdini, I don't think this is optional for anyone who wants to do this seriously. If you have Apprentice, you're only able to render out 1280 by 720, and that's not a big enough resolution to do anything professional with it. You don't want to do your demo reel at that resolution. You don't want to deliver any client work with the free version of Houdini. So you'll be left upgrading one way or another. If you qualify for the education, that's $75 right now. Indie is $270 for 1 year or $400 for 2 years. And then if you have a farm and you want additional licenses to render on that farm, then you can do an annual rental for $200, or there's different rentals here that SideFX has available. And so in general, you're looking at a base cost of, let's say, $270. With Redshift, you can pay either annually all up front. If that's the case, it's $264 for 1 year, or that works out to be $22 a month. Or if you want the extra flexibility, you can just go monthly, and that's going to be $45 a month for Redshift. Let's get more specific by breaking down the situation, okay? Suppose that you are a young, healthy, excited junior artist, ready to take on the world for about $67,000 a year. Well, with Karma, this is the pricing options there. So about $269 a year, that equals about $22 a month, or about 14 cents an hour during your 8-hour work week. Assuming, of course, that you are working the standard 40 hours a week. Okay? Redshift is about the same. And when we combine them, it totals out to about $533 a year, $44 a month, or about 27 cents an hour. Now, as a percentage of your total income, that's about 0.4% for just Houdini, about the same for Redshift, and combined, you're still under 1% of your yearly income for the software that's responsible for generating these $67,000 a year. Now, watching this, you might be from India. So let's try some alternate calculations, shall we? Let's say that you're from India and you make about $12,000 a year. That's about 3 to 4 times less than a McDonald's worker here in the States. Well, as a percentage of your income, that's 2.2% for both Redshift and Houdini. Combined, that's 4.4%. Spending that kind of money and reaching $12,000 a year is still honestly not that bad. And might I remind you, you're not just paying this money to make a certain amount every year, you're paying this money for the opportunity to make more going into the future. So now let's do an alternate calculation for a senior Houdini TD salary. And for that, we're looking at about $175,000 a year, assuming that you're working here in the West, you're in a more expensive city, and even if you aren't in a more expensive city, there are Houdini artists who are top of the line that make at least this amount of money. Well, as a total percentage of your income, you're now down to 0.15%, and then you're still under 1%. You're like at 1/3 of a percent for your total income. So, what's my point here? My point is that these costs are super, super cheap, especially relative to the opportunity that they offer you, especially due to the fact that these are your business costs. And these business expenses are minuscule compared to what it costs to do just about anything else. You don't think that construction companies spend a lot more than 1% of gross income on business expenses? Well, I can promise you that it's a lot more than 1%. They're out there buying power tools, trucks, gasoline, hiring skilled workers just to get up and at it doing anything as a business. And you too are a business in that you are investing this kind of money in order to get a return of up to, let's say, $175,000. If you're somebody who's thinking, man, Houdini's really expensive, I don't want to buy Indy, I just want to stay an apprentice, or, Redshift, oh, it's super pricey, I don't know. Again, I don't think you have a good perspective on the situation here, because relative to the opportunity and the money you could be making in the future, this is absolutely nothing. When it comes to visual quality, there's two parts that make up that answer. The first part is asking yourself, well, which one looks better? And you can go back to the render tests that I did for that question. And it's rather subjective, and depending on the situation, depending on the artist, you may find that Karma looks better, or you might find that Redshift looks better. There's a lot of factors that go into what makes an image look great, in your opinion. So I'm not going to really get into that, because that's just a subjective take on, what looks good. But we can ask ourselves a bit more of an objective question, and that is, for the average artist, are they more likely to make a great image with Redshift or with Karma XPU? I'm not talking about your super talented artists. I'm also not talking about your inexperienced artists. Just your average user. Are they more likely to have a professional image with one or the other? And what I've found historically with my students is that the answer is Redshift. And I think the reason for that is because of everything we just talked about. When you take a look at user experience, Redshift is easier to use. There's less headaches. There's less weird complications you need to contend with. There's less frustrations. When it comes to features, there are a lot more features with Redshift, and some of those features, like PostFX as an example, make a pretty big difference when it comes to the average user's render. And so when you take user experience and features and you add it all up, for the average user, they are going to make a better image with Redshift, which is why Redshift wins this render review video. I know that for a lot of you guys that might be upsetting, and honestly, I really wanted Karma to win. I want to just tell my students to just go with Karma. It comes with Houdini. It's easy. You don't have to install anything. But honestly, after doing this test and after looking at all the things we just looked at, I can't in good faith tell a student or a studio that they are going to get a better competitive edge with Karma as opposed to Redshift. I do think that the differences right now are very striking. Now, it is fair to say that Redshift has been in development a lot longer than Karma has. And so naturally, with extra years of development, it is a few miles ahead of Karma. And going into the future, I know that SideFX is very passionate about improving Karma. However, I go back to the average user, and I go back to the junior, the mid-level, the senior TD, who's being told right now that this is production ready, and this is gold. This is ready to go. And that's simply not true. Not when you compare it against its alternatives. What that's going to lead to is more beginners who burn out, more intermediate artists who have a hard time finding a job because their demo reels don't look as good as folks that used a different render engine, and advanced users spending long hours into the night trying to figure out how the heck USD is going to work in their pipelines. So there you have it. That does it for this review video. I want to thank you for spending so much time with me, and if you found this information to be helpful, then please make sure to share it with your professional network, because that helps me out. Until next time, good luck out there and have a great day.